Okay. Anyway, so let's keep going. All right, so last time, remember, what we were doing was, well, we did a few different things. One of them was finding the odds in favor or against an event, okay? And here I'm just kind of reviewing that just to get our feet wet again, I guess, so to say, if that makes any sense. So basically, we want to find the odds of rolling a die but not getting a 6. So again, in this case, we're going to look at the, the odds in favor of an event, but the event is not getting a 6. So that's what we're going to do here. And I just said here, and also again, as you can see on the slide, that the odds in favor of an event, it's the number of ways this event can occur to the number of ways the event cannot occur, okay? Again, that's just what it is by definition. It's not a probability, it's actually just, it's actually just a ratio. So that's what it is that's what the odds are by definition, okay? Now here though, the event is not rolling a 6. So how many ways can we not roll a 6? Well, remember on a standard 6-sided die, remember, there are 6 numbers, so we can roll any of the 5 remaining ones. 1, 2, 3, 4, 5. Basically, we can roll a number besides 6. So the number of ways the event cannot, so the number of ways the event can occur is 5, and the number of ways it cannot occur is 1. Basically, we do roll a 6. So we have 5 for the ways it can occur, 1 for it cannot occur, so we get 5 to 1. As you can see, 5 to 1, you can see. So again, that's how we write it. We have a colon. It's a ratio. Again, this is not the same. It's not the same as probability, okay? Not the same as probability. Probability is related to this, but it's not quite the same. Okay. All right. Now, so we could also find it actually using probability though. Remember, if E is the event, right? If E is the event that we're interested in, and the odds in favor of event E turn out to equal this. Probability of E divided by 1 minus the probability of E. Okay? Probability of E over 1 minus the probability of E. That's what we get here. I mean, it wasn't actually defined this way, but I did show last time that is how it can actually be calculated. That's what happens here. So event E in this case is that we do not roll a 6. Now, so what do we get? Well, we know the probability of not rolling a 6 is equal to 5 over 6. You know, we saw that, I think we just saw that now. So we have that. Then we're dividing by 1 minus that, as you can see. Now, 1 minus 5 over 6, okay? Well, that's the same thing as 6 over 6 minus 5 over 6, which is 1 over 6. You know, I'm just subtracting fractions. That's all I'm doing. All I am doing. So we have this. So we get 5 over 1, right? Because the 6 is canceled. That's actually an algebra thing I did last time. We get 5 to 1, right? So the 6's cancel, we have 5 over 1, but we write that as 5 to 1. And of course, that was the same thing as we just saw. So that's good. Right. So either way, we get the answer as 5 to 1. That's really what we want, so that's a good thing. All right. Anyway, okay, so we have that. And again, that's just kind of a refresher, so to say, from last time. I know I did email the notes. I didn't, what do you call it? I didn't get a chance to post them yet. Okay. All right. Anyway, here now is the actual probability. Here now is the actual probability. Okay, so so again, by definition, if all the outcomes are equally likely, that's really what we're dealing with here. That's in theoretical probability. That's really what we're dealing with here, okay? So if all outcomes are equally likely, then the probability of event E, right? E, again, an event is just a sub-collection of outcomes. The probability of that event E occurs is the total number of outcomes that correspond to the event E. I think I spelled corresponding wrong. Let me just fix that. How I missed that? Oh, whatever. It's the total number of outcomes corresponding to event E, and then you're dividing by the total number of equally likely outcomes. So that's what this is equal to. It's the total number of outcomes that correspond to event E, and then we divide by the total number of equally likely outcomes. And that's what the probability of E is. So that's what we have here. Okay. All right, so this is just another example. Let me just actually okay, so let me just do another example here. Remember also that, well, let me just say it one more time. I don't know if I said it right. The probability of event E, remember, is the total number of outcomes that correspond to event E. Then you're dividing by the total number of equally likely outcomes. So, all right. Now, we have this example. Remember, but we're choosing a card at random from a standard deck of 52 playing cards, right? That's what we're doing. Okay. Now, remember also that in a standard deck of 52 playing cards, okay, we want there's 4 suits, right? Each suit has 13 cards. Remember the suits are, what are they? Diamonds, hearts, spades, and clubs, right? Those are the 4 suits. Diamonds, hearts, spades, and clubs. And each suit has 13 cards, right? 2 through 10. And there's Jack, Queen, King, and Ace. Okay, so that's what we saw last time. We want the probability of drawing the 8 of diamonds. That's only one card, right? Each card is equally likely. They're not marked or anything. So we get 1 out of 52. What about drawing an ace? Well, drawing an ace, right? Well, there's 4 aces in the entire deck. Right? You have the ace for hearts, diamonds, spades, and the clubs, right? For each of the 4 suits, that is. So we have 4 out of 52. Again, every card is equally likely. So we get 4 out of 52 here. For the next one, the probability of not drawing a heart, okay? The probability of not drawing a heart, well, it turns out there are 13 hearts in a deck, right? So if we wanted to draw a heart, so what we're doing here is basically we're finding the probability of an event. We can look at the complement because that's a little bit easier. Well, here's not terrible, but to get the probability of the original event, so to say. But now, okay, but now we have the probability, we have 13, but now let's get the probability of, what do you call it, of the hearts. Well, we know there are 13 hearts in the deck, right? So if we wanted the probability of actually drawing a heart, there are 13 of them, so that'd be 13 out of 52. So what would the probability be of not drawing a heart then? Well, that would be 1 minus that. Okay? That would be 1 minus that, right? Which is 1 minus 13 out of 52. There we go. And get the laser pointer to work. It'd be 1 minus 13 out of 52. And 1 minus 13 out of 52, I'm just doing basic fraction stuff here, as you can see. Basically, here what I'm doing is, 1 is the same as 52 over 52, right? 52 minus 13, right? That's the same as, over 52, right? So we have 52 minus 13 over 52, like so, okay? And that's 39 over 52. So we actually found the probability by looking at the complement, essentially, is what we did. And once we got the probability of drawing a heart, we subtracted it from 1. That's all. You could actually get the probability directly because you know that if there are 13 hearts in the deck, there's 39 remaining cards. So we just choose one of those remaining cards, which is 39 out of 52. That's a good idea. I mean, so that's a solution.